All right. My name is Nick Feltz. I am an engineer with Praxis Engineering. I've been working lately with Mike Miller Runtime on GitHub to revamp the crypto and add some new functionality to it. So I'm going to be discussing that. There'll be time for questions at the end if anybody has some. So we have the obligatory outline slide, but instead of just giving you the names, I'm kind of discussing here what we're going to be talking about. We're talking about what we're encrypting, why we're encrypting it, how we're going about it, what are we doing to handle the keys, the development, so where we started, where we ended up, and all along the way we should be discussing some of the whys and what motivated things. So for those of you who are not crypto experts or maybe haven't even taken a class in cryptography, I've got a quick refresher we're going to discuss. So Accumulo is encrypted using symmetric encryption, and what that means is that you have the same key encrypting and decrypting data. It's much faster than asymmetric encryption. You also have two different kinds of keys, the key encryption key and the file encryption key. Each file in Accumulo has its own key that the data is encrypted with, that is then encrypted with a key encryption key attached to the end of the file. I don't think beyond this point I ever actually talk about file encryption keys. So when I talk about key management and what we're managing, I'm going to be talking about the key encryption key because that's really the keys to the kingdom. The algorithm that we're using for this is AES. That is what is actually doing the encryption. It encrypts very small blocks at a time, which is why we have to specify the mode. And the mode is what is used when you're encrypting more data than one AES block will handle at a time. The initialization vector is fed in with the mode. The goal behind the initialization vectors are to make sure if you have two blocks of plain text being encrypted with the same key, you don't end up with two identical blocks of ciphertext. And then padding is what you have to do to add data to the end of a block to make sure that it's the right size. Not something we go into much here. So what and why? Anybody who went to the first Accumulo Summit, gentleman Mike Allen spoke a lot about what was the motivation behind the way that they added the encryption and what you were trying to accomplish. A quick summary is you're protecting from somebody, you're allowing the segregation of responsibilities for your system administrators. So you can have somebody who is a system administrator who doesn't necessarily have access to your data. You can have an Accumulo administrator who does have access to the data but may not have sudo for other reasons on your system. And one of the big questions is, well, what do you get over full disk encryption here? Well, you get that segregation, but we're not saying use ours exclusively. We like to encourage people to use both. They solve two different problems. And within Accumulo, we have two different file types, primarily two different file types. There are other files that are used in various places, but the two big ones are the R files and the WAL files. And the R files are your long-term storage. They stand for relative key file, and that is your sorted data that you're going to be querying and looking up for years to come. Your WAL files are used to recover in the event of a system failure. So if the power goes out, if connectivity is lost, whatever's going on, and they capture a lot more than just the data that's being brought in, but they also capture the events that are going along. They're capturing when the data went in, what Accumulo is doing in the meantime, so that they can rebuild the state in the event of a failure. So this is a very 1,000-mile view of what an R file looks like. You have the very end of the R file is the tail, and it gives you the information that you'll need to decrypt, decompress, any other information you need to be able to read the R file. And it tells you where the meta blocks start. And the meta blocks are kind of like your phone book. They tell you where the various data inside the data blocks are located so that you can do quick lookups instead of scanning through all of the data. These are, again, your long-term storage. These are things that you're going to keep for potentially years to come. WAL files, they are structured very differently because they serve a very different purpose. They start out with a header where everything that you'll need to reread the file is written to start out with. So anything that you would need to decrypt, decompress, anything else you need goes in that header. And then the logger is just handed a file stream and told go. And it writes as much or as little as You have to be ready with walls, though, for the system to go down at any time. So the initial crypto work when we got started did not account for this and did not account for the fact that you needed two different ways of encrypting the data. For wall files, we are using what was already there, which is AES and CBC mode. What CBC mode allows you to do is encrypt, 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 encrypt with no set ending time, so that if power goes out, computer dies, it'll recover with the last bytes that were written. Our files, we put in GCM mode. GCM adds a bit of integrity by keeping a track of a hash of the data as you're going through and recording that at the end. So that works really well for your long-term storage where you've got time to go back, write out the data, you're already sorting it, you're doing these other things. And you want to include that tag at the end, but not so good for wall files because if you fail and the power goes out and you haven't written the tag, you can't recover your data. So the two different files require two different modes, and the file encryption key before was just being encrypted with AES, but there is a algorithm in Java, AES key wrap, which is now being used. And that is used for the file encryption keys at the end of each file, or at the beginning in the case of wall files, being encrypted by a key encryption key. So of all the things I'm going to talk about, especially in a little bit where we talk about revamping the code and some of the changes we've made, this slide's really the most important slide I'm going to have up here because the data integrity is a lot of value that you're getting. The explicit integrity ensures that any flipped bits is detected. So, be it a cosmic ray, a malicious administrator, whatever the case is, if a bit changes, the stream no longer decrypts and you know that there was a problem. Because the encryption happens at the R block level, you will know this R block has been corrupted, has been modified, something happened. An example, a good way to think about this is if you're using CBC mode and you had a book that was written. As a human, you might be reading along, and then when somebody flips a bit and it just continues decrypting, you start to get a whole bunch of gibberish and you no longer understand it. The machine doesn't know that it's gibberish. It doesn't know what it's looking for. And some of your data may not even be human readable, so there's no way for the machine to know that there's a problem. With GCM, it does the full decrypt and then checks the tag at the very end. So you get explicit integrity. You know what you read was what you decrypt, or is what you originally encrypted. It is a NIST standard. And it is a NIST standard that is approved for file encryption. It requires very delicate handling of the initialization vectors. GCM has really bad failure if you encrypt data with the same IV and the same key. So a lot of the code that is in Accumulo that handles this, if anybody goes and looks at it, you'll see that there's very careful handling and accounting for the IV so that there is no chance that we encrypt two things with the same IV. Java 9 and further have to support GCM as any provider must provide for ASGCM, and it provides hardware acceleration for GHash. So AES hardware acceleration has been in Java for a long time, but GHash needed by GCM was only put in Java 9. So you'll see a very big performance improvement, Java 9 and later, when running in GCM mode. However, you still can run it in Java 8. The overhead, if you're just testing, is noticeable. I wouldn't recommend doing that on any real systems, but for playing around, if you're building on Java 8, it will work. It's just a lot slower. So the initial crypto implementation was put into place, and it, like anything else as a first pass, had a lot of little bits that were done well, little things that were thought through, but kind of the cohesive picture was a little bit chaotic. So I'm going to kind of walk through it. You can see here that there are a lot of things going on. I've got some walkthrough. So the client would request a file writer, be it a WAL file or an R file. They would both go through what was called the crypto module, which would go talk to the key encryption strategy. Now, I'm going to discuss key management a little bit in more detail in a little bit here, but key management's really hard. Again, if you saw Michael's talk at the Versa Accumulo Summit, the last half of it was about how it's very difficult to manage keys because you can encrypt all your data, but if you don't protect the key, then your data is really not protected. So they had implemented a key encryption strategy, which was a very large amount of code that did. It was one of those things where they tried to account for everything, and so they wrote a lot of code that did very little. Basically, the key encryption strategy that shipped with Accumulo allowed you to read a key off of HDFS and cache it for further use. Hundreds of lines of code to do that. The key encryption strategy would give the key back to the crypto module, and you'll see here immediately something a little bit odd. The crypto module returns the key back to the R file and wall writers, but it also, for the wall file, wrote, remember that header at the beginning of the wall file that contained information, it actually wrote that to disk itself. It did not allow the wall file to do that. They would then create a file stream, and those would also write to disk. So incomplete is the fairest word I can give for that. There were some really good ideas there, but key management's hard, and it reflected in the code. And then there were two paths to disk for wall files, and that made it very unintuitive. Trying to ply through the code and figure out where stuff was being written, where the parameters were being written, where the encrypted data was being written, took a lot longer than it needed to because there were two different paths, and there was nothing obvious or intuitive about the way that was set up. So before just sitting down and hitting the ground running, we kind of set out some goals, some things we wanted to do to improve the crypto module. We wanted to make it self-contained. So one of the big things there were a lot of things touching the crypto module, things were in and out. We wanted to simplify the approach to say the crypto module is responsible for crypto and crypto-related decisions, and the file writers are responsible for writing files. We wanted to move the key management into a crypto module and make it fundamentally a part of it instead of having two separate paths there that were kind of hard to follow. We wanted the crypto module to be totally agnostic of file formats and vice versa. So we didn't want it knowing how to write out data for wall files to read. And at the same time, we wanted to be aware of calling context. So because we have two different needs for encryption for wall versus R file, the crypto module needs to know what's calling it. So it passes in now. Each file says what kind of file it is that's writing out. Again, and I've said this, but I'll say it probably many more times before we're done, we wanted the crypto module to make the crypto decisions. And the interface, so one of the ideas originally was that the crypto module and the key strategy were going to be pluggable, and that wasn't really the case. There was a lot of hard-coded in there, and writing your own would have been very difficult. The interfaces were a little scattershot. So we wanted to make it do two things. One, we really wanted it to be as minimal as possible. We wanted to allow people to write one without having to, fill out 10, 20, 30 methods. We wanted the methods that you were required to implement to be very straightforward. And we wanted instance-specific crypto not to be prohibited by design. By instance, I mean a specific Accumulo instance. So you could change how you're running your crypto from instance to instance. And so part of this is how we were managing how we were handling the keys and the redesign for that. So the original key management implementation was really incomplete. It was hard to do things like if you wanted to just say store the key on each individual node instead of HDFS and read it. That was a very non-trivial task, and you're just reading from a file. We needed something that was clear for how we were handling the key, something that was straightforward, that everybody could look at the code and say, okay, the key belongs here, here's where it came from, here's where it lives. The crypto module stores that information, and it needs to be able to rekey. Using the old system, if you were going to rekey, if for some reason your KEK was compromised and you needed to rekey, I think the only way you could have done it was possibly turn off encryption, reread the files, recompact them into plain text, and then change your key and restart your Accumulo instance and recompact all of your files. It would have been very convoluted, and I'm not even 100% sure that really would have worked. There may have had to have been some code slung. So the new key manager we're calling Key Utilities is its responsibility is handling things for the keys, like acquiring it. And so right now we've put in place a way to read it from file, and it just takes a file URI. So it could be HDFS, it could be your local file system, it could be anything that's going to take a valid URI. But we've opened it up so that there are clear places to put in things if you wanted to read from a key server, a card reader, a USB drive. The world is your burrito. Whatever you want to do there, there's a clear entry point for it. So the new design is much simpler. There's not nearly as much going on. The file writers will just request an encrypted stream from the crypto service. So they say, I've got a data stream I'm about to put data into, crypto service, give me an encrypted stream. Or if you have encryption turned off, the crypto service says encryption is turned off, I'm just going to give you back the stream you gave me. So every time a file writes, it will hit this. The crypto service on return also gives the files all the information they need to decrypt later and let the files handle where and how they store it. It should not be the responsibility, again, of the crypto service to make those decisions and write for the file writer. So it gives it a set of bytes and says, do with this what you will, give it back to me later, and I'll be able to decrypt. Again, only the file writers write to disk. The crypto service is entirely self-contained. All of your crypto-related decisions are within the crypto service. So if, for your instance, you were unhappy with AES GCM, you would have to go in and change out a crypto service. The key management is entirely within the crypto service. The crypto service now contains keys that it loads once and holds them for the life of the tablet server. And it's easy sometimes to come up with these different images and say, wow, look at the original code, how complicated, how convoluted this was, and then redraw it. And you haven't necessarily removed any of the complexity. You just kind of threw image magic. But in the big pull request that implemented this, there were about 1,600 net lines of code lost. So it was actually quite a lot that was removed, and a lot of the complexity was actually removed. So I've discussed some of these features, but one of them, the decrypting keck. So one of the use cases that could be troublesome is, let's say that we had two different Accumulo instances and I wanted to move a table over, and I said, hey, I've got these R files that were encrypted with a different key encryption key. We now can account for that. So long as your file knows which crypto service was used and how it loaded the key the first time, the crypto service on your tablet server should be able to use that same service and go retrieve the key for decryption. The configuration was moved into the instance, so you can have instance-specific key encryption keys. So if you had Accumulo running, but you had multiple instances, each instance could have its own. The crypto module is actually pluggable now. There's an interface that requires just 3 methods if you wanted to write your own. And I think we are at least pretty close, if not all the way, to where you could plug and pull just a jar file for the crypto service, provided it meets that interface. The key manager is very easy to scale now. You can write your own without having to become an expert in kind of complicated interfaces that didn't make sense. And the configuration is much simpler. So I don't know if there's any sysadmins here, but well, let's look at it. So the original crypto module that was in there before we did our changes, these are all of the values you had to set to configure Accumulo. Your sysadmin had to have a lot of crypto expertise. They had to really know what they were doing, and I'm guessing that's not really their job. It was extremely complicated. Some of the options were not very clear. You didn't know necessarily where to find these modules and classes if you wanted to change them out. The user had the option to set a RNG provider. I'm not sure many sysadmins know or care how many RNG providers exist. And the key encryption key management was complicated. It wasn't as powerful as it kind of looked at first glance. So we've cleaned that up, and now there's only 3 things that need to be configured because a lot of those options were moved into the crypto service. Again, let the crypto service make the crypto decisions. Very straightforward, very few values. At the time that these slides were put together, we had a service, and we had basically 2 things. One would tell you how to get the key, so from a key server, from a URI, from a USB card reader, whatever, and then some identifier. So in the case of a file, it would be a URI and a path. This has been simplified even further with after it was moved into Java properties, where now one of the options is just to have a keylocation.uri equals. So there's only two things that have to be turned on, but that was done after these were put together. So revisiting some of the goals where I discussed what we were hoping to do, it is very self-contained now. The code is in one location, so if somebody wanted to go look at it, it's real easy to find. It doesn't touch a lot of different places. It is responsible for key management. There are some variables that are the encrypting kek and the set of decrypting keks. They're agnostic of file types. It doesn't care who or what is writing. It just gives you back the encrypted stream and wishes you Godspeed. It does know what's calling it, so it knows if you're a WAL file or R file or anything that could be added in the future. Those are really kind of the two easy wins. It makes all of the crypto decisions, so if you wanted to change key size, for example, you would have to go in and actually change it here. The interface did not prohibit instance-specific crypto by design. It is very flexible. You have an initialization, a get encrypting stream, and a get decrypting stream. And the key manager redesign is something that is kind of a work in progress. We've only put in the file reader and writer, so there's more to do there. We did some tests to see how much overhead this added when using Java 9. So using Uno on a single node, just one machine. I put the build commit if anybody wants to replicate this. We tested with 3 million rows, and I ran each service 20 times. And you can see the speeds there. With the crypto service on, its fastest was actually faster than unencrypted slowest, which was very amusing. That happened early, and I was sure that I had done something wrong. But after 20 runs each, you could see that the average slowdown was about 7.26%, which is not bad. And it's really not bad considering I think we're basically in the worst case scenario where it's one node, one thing running all the stuff. It's doing all the writing. You're not splitting up the data among 3 nodes that are going to be writing and encrypting, a third of it. So this is kind of your worst case scenario test being on one node. And so I think that those numbers are very promising. But again, this was with Java 9. Running because with the Ghash acceleration. Doing some of the tests in Java 8, I did not test extensively, but it added like 30% overhead, so it was significantly slower. And for scanning and reading, that's something we started, but have not completed any tests that are comprehensive or worth really covering at this time. So that's something that we're currently doing. We should hopefully have something out we might put on the under the crypto section on the website soon. So things that are possibly coming up. In the event that you do have a system failure, your WAL files get sorted through a MapReduce job and they get dumped out into a map file that is unencrypted. This only happens during system recovery, so it's a pretty small window, but the data is written unencrypted. Moving those from MapReduce files to an R file sounds like a really good idea, but it's an awful lot of work. So we'll see if that actually gets done. That's something that I would like to see. We're looking at putting in more key management options. So a large part of the prior presentation talked about wanting a key server, but the problem is key servers are really expensive, and it's true. But there's some tools that weren't around back then, like PyKMIP, which would be great for testing and toying with. PyKMIP is a Python-based tool that implements the KMIP key management protocol, and we could theoretically write a client that speaks to the PyKMIP server, and if that works, if you actually replaced it with a key server, it should still work. So that's something we'd like to put in play. We'd like to study things like card readers, USB drives, other ways that people may want to get key encryption keys or store them. And we would like to explore potentially using multiple encrypting keks. Right now, each instance only has one. So if you wanted to do a rekey now, you would have to restart the instance with a new encryption key and then run compaction. It's hard to think of many compelling use cases for having multiple keks, but there might be some other than segregation of basically cryptographically enforced access control, which Accumula's already got a lot of access control built in. But But it's something that we want to explore, see if it's worth implementing, the best ways to do it, how we would go about it, how you protect keys while they're on nodes. There's a lot of questions that get opened up there. So that is one of the things we're looking at doing, or at least looking into. And so I ran through this kind of quick. There's my contact information. I got references, and I know that somebody raised their hand earlier. So questions. He asked how hard it is migrating an existing cluster. If your existing cluster is not encrypted, this should be pretty easy. If it is encrypted using the old crypto module, there's going to be some work. The code that would read those old files is no longer in the Accumulo branch, so you would have to. Right now, I think that the easiest path for that would be to dump them into plain text and then re-encrypt them. There could be an adapter written though. The old code, it's out there in the old commits. So it would be possible, I think, to write something that decrypted the stream and then re-encrypted the stream, but that does not currently exist. Right. So the crypto is hooked into the R file writer itself. So as each block goes through and writes, it gets its own encryption stream. It gets its own encryption stream, and each block kind of spits out its own thing. So if you're using R files in any ways other than live streaming and you have this turned on, they will be encrypted. So that was the thing that I was talking, I guess we're stuck on the references slide. When I was talking about exploring multiple encryption key encryption keys, that is not something that's in there now, but it's not prohibitive. It would not be difficult to add. We're talking about the advantages of that. So if you remember, each file has its own file encryption key. So that key is wrapped with the key encryption key. So if you compromise that, you then compromise all those keys, so you then compromise all those files. But your own files are already kind of protected in their own way. So discussing what you actually get out of having various users with various keys, the value added is really hard to determine. And you introduce a lot of potential complexity, right? So let's say that you've got your data, and if you want your own encryption key for your own table, you probably don't trust people who are controlling the system. But if that key is loaded onto the node, how do you feel about that? Where's the value added? I don't know. There may be a really compelling use case. That is something that we've been looking at, and I wish I had a clear answer. Maybe one day I'll be back up here with that answer for you. Right. So he's saying that there's row-level encryption. Right. So there are certain advantages to table over that. I mean, everything is pick your poison, right? There's pros and cons. By doing the table level, you can take advantage of really nice compression before you do the encryption. But again, it's a matter of where you have your trust. We're access control in Accumulo. I think if you ask most people, hey, does Accumulo have built-in security? Everybody will say yes. And what do they mean? Well, it's got really rigorous access control, which is really good. But we're kind of depending on, okay, if you've already got your access control in place, we're not trying to cryptographically protect that, at least right now. Anybody else? It is. So as the API changed, I think on Friday, these are still marked as experimental as we're finishing out some of the details. So it will be part of Accumulo 2.0. It is something that is worth playing with, but it is something we're still polishing up. All right, there's no more questions. Then enjoy the rest of the conference.